हेलो गाइस, मेरा नाम मोहम्मद इजान खान है and currently I'm pursuing my degree in civil and environmental engineering from IIT Patna, right? So I'm in my sophomore year. Yeah, so I'm in sophomore in my college currently. So let's start. So we were doing questions on limits and derivatives, and I had done till question number 47. Now I have to start from 48. So let's begin. Okay, now we have to find the limit for this value. Got it. So it's a big question. Let's see. So question number 48. Right. What do I have here? Limit x tends to a zero. There's an x. There is alpha x plus beta x. Yeah. There's a plus sine alpha x minus beta x. All right. And there is plus sine 2 alpha x as well. And in denominator, what do I have? Cos of 2 beta x minus cos of 2 alpha x. Yeah. So I can see that in the sign, I have a sine a plus b and sine a minus b form. So I can, further simplify it and write it as sine a cos b plus cos a sine b. So sine alpha x cos of beta x plus sine of beta x cos of alpha x cos alpha x. All right. And plus sine alpha x cos beta x minus sine beta x and cos alpha x. And for sine 2 alpha x, I can write this as plus 2 sine alpha x and cos alpha x. All right. This whole thing is divided by a cos 2 beta x minus cos 2 alpha x. All right. Sine beta x and cos alpha x, sine beta x cos alpha x is getting cancelled out. Yeah. And then I'll be left with a limit of x tending to a 0. There's an x over here. There's a 2 times sine of alpha x beta x, alpha x cos of beta x, plus 2 sine of alpha x cos of alpha x. Yeah. And in denominator, cos 2 beta x can be written as 2 cos square beta x minus 1. And cos 2 alpha x can be written as minus 2 cos square alpha x. And here there will be a plus 1. So this also got cancelled out. Now limit x sine alpha x whole divided by 2 sine alpha plus beta by 2 x in sine alpha minus beta by 2. Okay. And there was an x also over here. So this x and this x will simply get cancelled out. And if I take this alpha plus beta by 2 as some u and alpha minus beta by 2, I'm sorry, as some v, then I can write this whole thing as half of limit x tending to 0 sine alpha x multiplied with limit of x tends to a 0 x by sine ux, okay, multiplied with limit x tending to 0 1 upon sine vx. Yeah. So now 1 by 2 a limit x tends to a 0 sine alpha x. If I divide and multiply with alpha x, I'll be left with this. All right. Next part multiplied. So if I just give an extra u here, I can write this as 1 upon limit of x tends to 0 sine ux upon ux. Okay. And multiplied with 1 upon whole thing vx. limit x tends to 0, sine vx by whole thing by vx. So half alpha x upon into 1 into 1 into 1. So 1 by 2 alpha uv. So it was alpha plus beta by 2 and alpha minus beta. I'm so sorry, alpha minus beta by 2. All right. So if you just simplify it further, you just have to multiply it. Then you'll get what? Let me check. What was it? Yeah. So it will be 2 alpha times alpha square minus beta square. This will be your answer. Let's move on to the next question. Next up, we have question number 49. Pi by 4. Alright. Now, if you just open this a square minus b square term, we'll be left with this tan x minus 1 times tan x plus 1. Okay. And in denominator, I'll be having what? Cos x minus sin x. Now this tan x, what can I do with this? There's also an under root 2 term. Okay. Yeah. So root 2 times limit x tends to a pi by 4. And if I just open this tan x as sin x upon cos x, so what will I be left with? There is a tan x over here. There's a sin x divided by cos x minus 1. Sin x divided by cos x plus 1 whole divided by cos x minus sin x. So if I take a cos x common from this whole thing, right? So let's move on. If I take cos x common, there is an under root limit to x tending to a pi by 4. Here I have a tan x upon cos x term, right? In the numerator, I have a sin x minus cos x. In denominator, I have a cos x minus sin x now. And what further? There's a tan x plus 1 term also, tan x plus 1. So this is getting cancelled out, and there's a minus term here now because you get my point, right? So minus under root 2 times. Now I'll just put in the values for x. Inside I have a tan pi by 4 plus 1 divided by cos pi by 4. So minus under root 2 into 1 into 2 by 1 upon under root 2, right? So that will leave me with root 2 times 2. So it is 2 times 2 minus, and it is a minus 4. That will be your answer. Okay. So let's move on to the next question, which is question number 50. So in question number 50, we have been given the limit for x as what? What is it written? Pi. Yeah. So x tends to a pi. And 1 minus sine x by 2 divided by cos x by 2 cos x by 4 minus sine x by 4. Alright. Now what can we do with this? Sine x by 2, I can write this as 2 sine. Yeah. So let me tell you one thing. 1. Can I write this as sine square x by 4 plus cos square x by 4? I'll tell you why I put x by 4 over here. You'll get my point when I'll just put in the values over here. And what can I do with this sine x by 2? X by 2 is here. It will be 2 sine x by 4 cos x by 4. Simple. So if I just put in these values over here, I'll be left with a sine square x by 4 plus cos square x by 4 minus 2 times of sine x by 4 and cos x by 4. And in denominator, what did I have? In denominator, I had a cos square x by 4 minus sine square x by 4. and the whole thing multiplied with cos x by 4 minus sin x by 4. Yeah. So there's a larger term over here. I'll just put in that value. So now this whole term over here, this will return a value for what? Sin x by 4 minus cos x by 4 ka whole square. Or you can just turn it the other way around, plus and minus. And in denominator, what am I going to have? I'll be having a cos x by 4 minus sin x by 4 multiplied with cos x by 4 plus sin x by 4, and further. All right, so this will get cancelled out. Yeah. And what will be what will we be getting over here? So our term over here will be cos x by 4 minus sin x by 4. The square term will get cancelled out. No, let's not be so hasty. Let's just write it completely in C. Cos x by 4 minus sin x by 4. Okay, and I had a cos x by 4 minus sin x by 4 over here as well. And what was that larger term that we missed out? Question number, yeah, sin x by 4. I can also write that as cos x by 4 minus sin x by 4. So there's a square term over here. This whole thing will get cancelled out. So what I have to do is put the limit for x tends to a pi over here. Okay, 1 upon. So this will be 1 upon 1 by under root 2 plus 1 by under root 2. So 1 upon 2 under root 2. So under root 2 by 2 will get me 1 upon under root 2 as my answer. So let's move on. Next up, we have question number 51. In 51, we have a modulo function, right? There's a modulus function. If fx is equals to a mod of some value x, then this function returns a value of minus x for positive x for. Alright, this is a modulo function. So the function that has been given to me here is x minus 4 modulo. So it will return a value of minus times minus x minus 4 for what? For this whole thing, x minus 4 being less than 0. That means that x is less than 4, and it will return a positive value for x minus 4 for x being greater than 4. All right. So this is what this value returns me. So I'll just open that. We have to show that the limit does not exist, right? So at x is equals to 4, I'll be approaching from the left hand side and the right hand side as well. So if you approach from the left hand side, okay, let's approach from the left hand side. So the left hand limit is x tends to a 4 minus, right? It is slightly, we stop slightly before we reach 4. If this is your number line, this is the number 4, we are moving like this from the left hand side. We just stop like here. The distance between these two is very less, epsilon. Okay, you're getting my point, right? So what happens is, if you stop there, your modulus will return a negative function, minus x minus 4, and in division also you have x minus 4, so you'll be getting a value of minus 1 if you approach the limit from the left hand side. Now conversely, if you approach the limit from right hand side, this is your number line, this is your number 4, you have crossed this number 4 and you are somewhere here. Just after you have crossed 4, you stop. So your x is tending to a 4 plus. Here your modulo will return a positive value because x is greater than or equal to 4, and we are dividing it by 4, so it is going to leave with the value of plus 1. So the left hand and the right hand limit are not equal. Left hand limit is unequal to the right hand limit, so limit does not exist. Basically what happens is, for the modulo function, this is what happens. Suppose this is some point x minus a mod whole mod. The modulo never lets the value get to negative. Okay, so if you just cross that value, it will, just invert it. There will be a negative sign. So it moves like this. This is the modulo function. So if you approach it from the left and from the right, the limit values are different. That is why it does not exist over here. All right, let's move further. Question number 50 first we have done. Now, let's move on. Question number 52nd. So basically, what we have not drawn it properly. Let me write it for you. Question number 52nd. Question number 52nd is given to you as this: fx k cos x by pi minus 2x when x is unequal to pi by 2, and this is equals to 3 for x equal to pi by 2. And given condition, we have been given that limit x tending to a pi by 2 for fx is equals to f pi by 2. Then we have to find the value for k. Okay, let's see what we can do with this question. So if I just put in the value from the left hand side first, so approaching from the left hand limit, my limit x is tending to a pi by 2 negative. There's a k cos x by pi minus 2x. And on approaching, I'll just put in the value for the function that has been given for me. So if it's unequal to pi by 2, then I have to put this value. So k cos pi by 2 minus x divided by pi minus 2x, right? All right. Now this is equals to k sine of pi by 2 minus x. Okay. Basically, it was k cos x. I can write cos x as pi by 2 minus x because cosine is positive in the first and second quadrant. All right. So k cos pi by 2 minus x, I can write this as k sine pi by 2 minus x. I'm sorry, cos can be written as this. Okay. It was k cos x divided by pi minus 2x can be written as k sine pi by 2 minus x, and the pi minus 2x in the denominator as well. All right. So this whole thing has been divided with what? Pi by 2 minus x, and pi by 2 minus x is over there as well. So I'll just take k by 2 out common. Yeah, I'll take k by 2 out common, and there's a limit for pi by 2, and there's a sine pi by 2 minus x divided pi by 2 minus x. So the same thing, if I take pi by 2 minus x is equals to y, then sine y by y, where y is tending to a 0, it will return a value for 1. So k by 2 is when I approach the value from the left hand side. So this is the LHL value, k by 2. All right, we'll keep this in mind. Now, in order for the function to have a limit on that point, it must have its LHL equal to RHL. So now we have to find its RHL. So its RHL has been given as fx is equals to limit when we approach from the positive side. This is a k cos x divided by pi minus 2x. Yeah. So k by 2. K by 2 and limit x tends to a pi by 2 plus. So it is again making this whole thing like sine y by y, where y is tending to a 0. And again, this value will return a value for 1. So it will be k by 2 as well. So my RHL is equals to my LHL is equals to RHL is equals to LHL is equals to k by 2. So from here we can conclude that the limit for the function exists. Now, what can we do further? We can just put in the value for k by 2 for itself x equal to pi by 2. Now, like from the sandwich theorem, we all know that we have to find the limit of some point a. And if the limit at a minus is equals to the limit at a plus, then it will definitely be equal to the limit at a. Like if f a minus is equals to f a plus, then f a minus is equals to f a is equals to f a plus. ठीक है. So we have found the value for k by 2 for x minus and x plus. Now simply we have to find the value at that point itself. So we'll just put in that value. K by 2 is equals to limit x tending to pi by 2, x tending to pi by 2 for fx. K by 2 has been given equal to 3. So k is equals to 6. So basically, in this question, the main thing was that sandwich theorem. We have to keep that in mind. Like you found the limit for the left, you found the left hand limit, you found the right hand limit. It must click your mind that you can use the sandwich theorem and find the value for the limit at exactly that point, right? And then you'll get your value for k. All right. Let's move on further. So now next up is question number 53rd. In it we have been given that fx is a function, right? Its value we have been given to us as x plus 2, where x is less than or equal to minus 1, and cx square when x is greater than minus 1. So they want us to find the value for c if limit exists at x equal to 1. Okay. So if we just equate the LHL and RHL, I think that it will end up our question. So if I just find the limit for x tending to, we get this minus 1, right? So minus 1 negative for fx, it must be equal to limit for x tending to minus 1 positive for fx. Putting the value for less than minus 1 and greater than minus 1. So less than will come in that minus 1 minus. So it must be greater than minus 1 for that to exist, right? So less than minus 1 is x plus 2. Yeah. So I have to put in this value here, x plus 2, where limit x tends to minus 1 slightly less. And in this part, my x is going to cross minus 1, and my fx value is what? Cx square. Right? So simply putting in the values here, I'll be having a minus 1 plus 2 over here, and c over here. So c is equals to 1. All right. So the next question, now we are moving forward to the objective type questions, right? So let's see. Choose the correct answer out of 4 options. Let's see the first question. First question is question number 54th, where our limit x is tending to a pi. There's a sine x, there's a x minus pi. Okay, plugging in the values for x tending to pi, x tending to pi. Sine x can be written as what? Sine pi minus x. When we subtract an angle from pi, the sine cos remains the same. Okay, and in the second quadrant. Okay. Yeah. So there's a minus. The minus sign will also come over here. Okay. So it will be minus sine pi minus x whole divided by a pi minus x. All right. Now we know what to do. Limit x tending to pi by. This whole thing is attaining a 0 by 0 form. So it will be a minus, and this value is 1. So the answer is minus 1. Now, so minus 1, where is it? Question. It is C. So this one. Yeah. Next up, question number 55th. It is given that limit for x tends to a 0, where it is given x square cos of x all divided by 1 minus cos of x. Okay. Now, what can I do with cos? Yeah, 1 minus cos x is there. I can write that as 2 sine square x by 2. See, 1 minus cos x ko, how can I write this? 1 minus 2 sine square x by 2, right? 1 minus 1 minus 2 sine square x by 2. What I'll suggest is, like, it's good that if you remember the formula, like this whole thing, 1 minus cos x can be written as 2 sine square x by 2. This will ease up your time, and there's a possibility of making an error. Whenever there is a minus sign and there's a whole bracket thing, you plug in all the formulas and all, you can make an error. You can blunder up this minus minus or minus plus. So it's better if you remember the formula for 1 minus cos x as 2 sine square x by 2. It will be helpful for you, right? Now x square cos x is there, and 2 times sine square x by 2 is also there. If I just multiply it and divide by 2, I'll be having a 2 cos x, 4 sine square x by 2 divided by an x square. If I just take it down, so it is 2 cos x sine x by 2 by x by 2 a whole square. Limit x tends to 0. So I'll have a 2 into 1 by 1 per square. So the answer is 2 over here. So option number A. Now next up we have question number 56. So question number 56, we have been given limit x tends to a 0, 1 plus x raised to the power of n minus 1 by x. Okay. So what can we do in this? Plus minus 1. Yeah, that can help us. 1 plus x raised to the power of n minus 1. X plus 1 and minus 1 will also be there. So I'll just put 1 plus x equal to a y. So when x tends to a 0, y will tend to a 1. Alright, y tends to a 1. Now, my new limit, y tends to 1, yn minus, alright, and y minus 1. So n minus 1, n minus 1 is nothing but n. So the answer for this one is A. Alright, let's move on to question number. Next up is question number 57. So in question number 57, we have been given the limit as x tending to 1, xm minus 1 divided by xn minus 1. Alright, what can we do in this? Multiply and divide with this. Yeah, then it will just take us back to that previous question we just did. Okay, x minus 1 by xn minus 1. Alright, and limit for x tends to a 1. Alright, so what do we have here? This one is by m and a minus 1. So m1 m minus 1 into 1 upon n 1 m minus 1. Answer will be m by n. Now, do we have any option? Yeah, B. Let's see the next question here. So next up we have question number 58. Yeah, so question number 58. Limit. We have a theta here. X should not be here. There should be a theta. Theta tends to a 0. 1 minus cos 4 theta. 1 minus cos 6 theta. We know the formula for cos 2 theta can be written as what? 1 minus 2 times sine square theta. Alright. So what will be for cos 4 theta? 1 minus 2 times sine square 4 theta. Oh, I'm sorry, sine square 2 theta. Then we can, expand sine 2 theta further. Let's see what helps us in this situation. So I told you 1 minus cos 2 theta is simply sine square theta by 2, sine square theta. So just write it like that. So here I'll be having a 2 times sine square 2 theta whole thing divided by 2 times sine square 3 theta, where the limit of theta is getting equal to 0. 2 by 2 will get cancelled out. So for theta tending to 0, yeah, theta tending to 0, I have a sine 2 theta a whole square. I just put in 2 theta ka whole square over here, and what? 2 theta ka whole square will be 4 theta square over here. Alright, multiplied with what? 1 upon 3 theta ka whole square into 1 upon sine 3 theta ka whole square divided by 3 theta ka whole square. So 4 by 9. 4 by 9 times 1 ka square into 1 ka square. Answer will be 4 by 9. So the answer to this problem is 4 by 9, first option. Next up, we have question number 59. Question number 59. So I'll be having cosec x, limit x tending to a 0, a cosec x minus a cot x by x. Okay. So I think that there can be sin x by x form. Let's see my limit x being equated to 0. So 1 minus cos x upon x into 1 upon sin x. Yeah. So, and the limit is also there. So let's see what we can do from here. 1 minus cos x can be written as what? Again, 2 sine square x by 2. So 2 sine square x by 2 whole divided by an x times 2 times sine x by 2 and cos x by 2. Okay. So limit of x getting equal to 0. There's a tan x by 2 over here and there's an x over here. Multiply and divide by a 2. I'll be putting a 2 here, so I'll have to put a 2 over here. This part is getting equated to 1. 1 by 2. Alright, so 1 by 2. This one. Next up is question number 60th. In question number 60th, we have been given what? 60. Yeah, so there's a limit on x. There's a sine x term, which is whole divided by 1 plus x minus 1 minus x. Simply just to simplify it, we can multiply and divide with the conjugate of this. So sine x multiplied with under root of 1 plus x minus under root of 1 minus x. 1 plus x minus 1 plus x. So there will be a 2x over here. Right? Now, yeah. So I can take this half out. There's a limit on x. There's a sine x by x term. And there's again a limit on x under root of 1 plus x minus under root of 1 minus x. Okay. So half times 1 times when x equal to 0. So it will be 0. So the answer is going to be 0 over here. So the answer for this question is 0. 60th of B. Let's do question number 61. So it has been given to me that limit for x tending to pi by 4 sec square x minus 2 tan x minus 1. Okay. Sec square x minus 2 can be written as sec square can be written as 1 plus tan square x minus 2. So it can be written as tan square x minus 1 divided by tan x minus 1 can be written as tan x plus 1. Alright, because tan x minus 1 and tan x minus 1 will get cancelled out simply. And the limit for this was x tending to a pi by 4 and here I'm left with tan x plus 1. So 1 plus 1, 2. Answer for this question will be, oh, so there's no option as 2. Where am I wrong in this? Let's do it again. So there was a 1 plus tan square x minus 2. Okay, correct. Whole divided by tan x minus 1. So there I'll be left with a tan square x minus 1 divided by tan x minus 1. Can open it as tan x minus 1. And the tan x plus 1 divided by tan x minus 1. All it's tan x plus 1 is the thing that is left here. And limit x tends to a pi by 4. Tan at pi by 4 equal to 1 plus 1. We return a value of 2 definitely. 1 plus tan plus sec square. Tan square x plus 1 equal to sec square x minus 2. Yeah. So this must be 2. Okay. This must be a misprint. This must be a 2 and that is your correct answer. So let's move on. Now question number 60 seconds. In question number 60 I have been given limit x tends to a 1 and there is an under root x minus 1, 2x minus 3, 2x squared plus x minus, right? So I can write this part as, yeah. So now this 2x plus 3 in numerator and denominator will get cancelled out. So I'll be left with what? Limit x is tending to a 1 under root of x minus 1, 2x minus 3. No, I'll be having a 2x plus 3 in denominator, right? Okay. So from where x minus 1 and under root x. Okay, I'm so sorry. This is what? Under root x minus 1. So this x minus 1, I can write this as, okay, right. So under root x minus 1 times 2x minus 3 time divided by 2x plus 3. And there is an under root x minus 1. And there is an under root x plus 1. So, and my limit for x is going to 1. So 2 minus 3, there's a minus 1 over here. And 2 plus 3, 5. And into 2, so minus 1 by 10. This will be the answer. Now moving on to question number 63rd, which is so the minus 1 by 10 was the answer, right? Here we have minus 1 by 10. Now question number 63rd. So in question number 63rd, we have been given GIF. So what is basically the GIF? Let me tell you that. GIF stands for greatest integer function. So GIF, you denote it with this. Now it is a step function. What is a step function? Like suppose you have put a value of 1 minus 2 in this. So the greatest integer which it contains is 1. So it will return 1. Getting my point? And suppose you have put a value of let's say 1.8. Again, it's the same thing. It will return the value of 1. If you put a value of minus 1.2, tell me what will it return? It will return a minus 2. Why does it work like this? Always imagine it is a number line. This is a 0. Okay. What happens is like this is 1. If you are somewhere in this region, the GIF will return this value. And after you have crossed this bar, like you are from in this region, then it will return this bar value. Okay, it returns the bar values. Here I have a minus 1, here I have a minus 2. Okay, so I gave you a value of minus 1.2. So it was in this region. So it will return the bar value of minus 2. Suppose I had gave you a minus 0.1. So you were in this region. So it will return minus 1. If you put a GIF over here, it will return a minus 1. So this is how it behaves. This is the GIF function. Now let's get back to the question. So question दिया है हम लोग को fx is going to have its value as sine of GIF of x divided by GIF of x when x is GIF is unequal to 0, and this will return a value for 0 when GIF is going to return a value of 0. All right, ठीक है. तो मैं लेफ्ट हैंड से अप्रोच करूँ इसको. The left hand limit for this is limit x tends to a 0 negative for my sine GIF x upon GIF of x. So if I put x मेरा जीरो से थोड़ा सा पहले रुक रहा है, सो आई कैन राइट दिस एज जीरो माइनस एच, जीरो से थोड़ा सा पहले। ऑलराइट, सो फॉर x टेंडिंग टू जीरो माइनस माई एच मस्ट टेंड टू जीरो। ऑलराइट, ठीक बात है। जीरो माइनस का मतलब ही क्या है कि जीरो ही है, बहुत क्लोज है जीरो के, बस लेकिन उल्टी तरफ से अप्रोच करने पे। सो एच मस्ट बी टेंडिंग टू जीरो फॉर एक्स टू टेंड टू जीरो माइनस, एंड फॉर एक्स टेंडिंग टू जीरो प्लस एच होगा, और एच टेंड करेगा जीरो को। ऑलराइट, फर्क समझ में आ गया ना दोनों में? तो नाउ लेट्स राइट इट अगेन, लिमिट एच टेंड्स टू अ जीरो where sin 0 minus h divided by 0 minus h. Now as h is tending to 0, h is approaching 0, तो क्या हो रहा होगा? मैं कहता हूँ कि 0 minus 0.00000 लिखते चले जाओ and there will be a 1. Okay, h is approaching 0, right? So this will return a value of what? Minus 0.0000000 and so on till what? 1. इसका GIF क्या होगा? ये मेरी नंबर लाइन है, ये मेरा जीरो है, ये मेरा माइनस वन है, ये मेरा प्लस वन है। जीरो से थोड़ा सा पहले इस जगह पे है, मतलब इस रीजन में, उसके पीछे वाला बार पहला कौन सा है? माइनस वन। सो ये वैल्यू रिटर्न करेगा माइनस वन की, है ना? सो साइन ऑफ माइनस वन डिवाइडेड बाय माइनस वन, लिमिट एच टेंड्स टू अ जीरो, सिंपली माइनस साइन वन बाय माइनस वन, सो साइन वन। ये रेडियन में होगा वन, ठीक है? तो ये हो गया हम लोग का लेफ्ट हैंड लिमिट। एंड नाउ फॉर द राइट हैंड लिमिट we'll just do the opposite thing. We'll approach from the right hand side. We'll be getting a 0 plus. And again the same function, gif of x divided by gif of x. So x has been given to me as 0 plus h. Now as x must approach 0 plus positive, h must be tending to 0. Alright. Now I'm just going to write it as h tends to 0 and sine 0 plus h divide by 0 plus h. Now as h is like 0.0000001, it is greater than 0. The greatest integer trailing that number is 0. So sine 0 by 0. And for h equal to h tending to 0, that will return a value of 1. Okay. So now we see that, wait a minute, sine 0 by 0, yeah. So sine 0 by 0 was there. So this means that LHL is unequal to RHL. LHL is unequal to RHL. That is why. So, so the answer will be none of the above. So in question number 64, again we'll follow the same approach. So first I have an LHL. Limit x is tending from a 0 minus, and there's a modulo this means that my limit for h tends to a 0. Alright, so limit h tends to 0 modulo sine 0 minus h divided by 0 minus h. Alright. So since I can see that this 0 minus h term, this is less than 0. Alright, why is it less than 0? Because no matter how small the value for h is, it is making it less than 0. It is approaching, h is tending to be 0, but it is not equal to 0. 0.00000 till forever. Alright, so it is basically a negative value, although very small value, but still. So this modulo will return a negative sign as well. So minus limit for h tending to 0 sin h by h. What does it return? It returns a 1. So minus 1 is the LHL. Alright, simple enough. Now let's see what happens when we approach the same limit from the right hand side. So right hand limit, limit x tends to a 0 positive mod of sin x by x. Right hand limit x tends to a 0 plus, and I have a modulo of sin x upon x. So I'll just put my x equal to 0 plus h. Okay, so when my x is approaching a 0 plus, then my h must approach a 0. Alright, that is correct. So the limit for h tends to 0 becomes modulo of sine 0 plus h divided by 0 plus h. Alright. Now since this value 0 plus h is greater than 0, alright, so it returns a positive value. So I'll just be left with limit of h tending to 0 sine h by h, which is nothing but 1. So my LHL was minus 1 and my RHL is 1. Since the left hand and right hand limit are unequal, LHL is unequal to RHL. That means the limit does not exist. Got this? Now moving on. So we have been given a function fx which is behaving in this manner. X square minus 1 for when x is from 0 say 2. Alright. And 2x plus 3 when x is from 2 to 3. 2 say 3. So the quadratic equation whose roots are limit, okay, from the left hand and right hand side. All right, so we have to find the we basically just have to find the LHL and RHL, and then we can find the quadratic equation as well. So limit x 2 minus fx 2 minus, this can be used x square minus 1 for x2 minus. We'll just have to put, we can put the value 4 minus 1, this is 3. And for limit greater than 2, x tending to 2 positive, fx, we can use 2x plus 3. So at 2, 4 plus 3, 7. Alright, so 7 3s are 21 and 7 3s are 10. This D. So D will be the correct answer. Alright, so let's see the next question. So next up is question number 66. Alright, there's a limit on x which tends to 0. There's a tan 2x minus x all divided by 3x minus sin x. So I can write this as tan 2x upon x minus 1 all divided by x 3 minus sin x by x. I just put in the limits inside. Limit x is tending to a 0. So tan 2x by 2x will return a value of 1. So 2 into 1 minus 1 divided by 3 minus 1. Alright. So 2 minus 1 is 1 and 3 minus 1 is 2. So 1 by 2 will be the answer for this one. 66th ka B. So next up we have till question number 80. So 14 questions are left. These I'll do in the next session.